quantum mechanics exercises, and we will be back at these. Finally, let's see if we can just close that problem. I hit just the first one, and I'm like quite stuck at it. But okay, let's see. But I think I've basically gotten enough of my refresher that I needed. So we're like in B, and we wanted to show that this is independent of time. And so initially, right, and so what we said was, well, we have like the psi x of t that would basically be a psi. So sorry, the other way around. So I'll delete that like this, and then we'll just say, well, it's this kind of like whatever constant, like not constant, but like the whole thing with the sort of the actual Hamiltonian, right? So of the system, which either was like I or like Planck constant times the thing t. That's like what's, I guess, time dependent, right? Uh, I don't know, or whatever. It doesn't. I think it doesn't really. It doesn't really actually matter. Maybe it matters. I don't know. But yeah, and then basically times sort of psi sort of x of 0, the initial one, which is basically, the 1 over square root of 2, and then psi 1 of x plus psi 2 of x, right? So, these basically distributes, and then we have that. But what we want to have is we want to have um, the density, the sort of probability density thingy, right? So we do the norm squared of these, but then this is the um, I'm gonna just like abbreviate that as in like a a function of a function of like a as a function of time, like um, no, maybe that makes it more complicated. I just don't want to write the whole thing because I think things cancel out, and I think that's the reason why it's time independent, right? Because sorry, this is like that. So essentially what you get is like this E whatever thing that it's like, or I'll just say A times T, like this A being all this other mass, right? And the square root of 2 times psi 1 of x plus the same thing, square root of 2 times psi 2 of x, right? Um, and so that will be time independent, but I think that now the idea is if we need to multiply that by its conjugate, I think is the conjugate of the sum is the, yeah, the sum is one. Okay, so is the conjugate of the sum uh, is the sum of conjugates? I think so, but I don't know. Now the thing is, um, the conjugate of the sum of two components is equal to the sum of the conjugates of two numbers. Yeah. Okay. So the thing is the following. No, what am I doing? Wait, have I? Oh, I'm so stupid. That's where I have the actual file. Didn't I have the file here? No, here. Ah, okay, cool. Now the whole thing here, right, is that because this thing is complex, right? So yeah, that thing here. Sorry, this is the solution, right? But that's kind of like what I'm trying to minus I times E times T divided by H blank, H blank, H bar. Um, so it's complex. A is complex, right? The time is complex. So this means that the conjugate. So this means basically that it's like, um, the these times it's conjugate, and so you're gonna have basically um, like um, e to the power of a t psi 1 like the conjugate of that, I just don't want to write the whole thing, right? But the conjugate of that times that in of itself, right? Now, I think because you know, um, are these complex like are these psi things? These are eigenfunctions, but they don't tell us. But like in theory, you would kind of say, well, it's the conjugate of these times these. So the thing is, the conjugate of these is the same with minus here, right? So I think because that's a complex part, right? So that basically means it removes the t component because if I do like e and at, and I know that a is complex, right? So times so the conjugate of these times itself, right? It basically will tell me it's like a t times e and then minus at, right? And and that basically means e to the power 0, which is 1, isn't it? Yeah. Is e to the power 0 1? That's just a big question. I think everything to the power 0 is 1, right? Um, yeah. I think that's true for everything. So that's why I think that's why these is going to be time independent because, and we're going to have to take a look at the factors here. But like so if this is a and this is b, and that's bad that I'm doing that, right? I guess the whole expression, right? It's going to be well, let's say if this is p and this is q, right? It's going to be basically p conjugate plus q conjugate, right? Times p plus q. So this will equal. Okay, guys, give me a second. I have to disconnect for a second. I'll be back in a second.